Hi, good morning, everybody. And it's not really too early right now. It's about 10:30 when I'm doing this recording. Outside is pretty good weather, and the sun's supposed to come out. So I'm so looking forward. And so today in this lecture video, we're going to talk about the section 10.3, the second part. So the second part is we're going to deal with is the rational functions. So the first part, we talk about the polynomials, right? So we talk about the different characteristics about the graph and those things. So what is the rational functions? So let's take a look here. Let's start here. So the rational functions. Okay, so this is the functions here. It's the ratio of the two polynomial. So this is the px and the qx. Okay, so the both px and the qx are the polynomials. Okay, that's what we talk about is the polynomials here. And of course, in here, the qx, right? So the qx is here, and qx cannot be equal to 0 because the, because of the, we cannot have 0 at the denominator. So in here, we have a few characteristics about the rational functions, and we want to, know. So we're going to talk about several. So first things here, we're going to talk about what is the vertical asymptote. Then we're going to talk about what is the horizontal asymptote. Then we're going to talk about holes. Some people call this is zeros. Okay, and so that's that's what is the holes is here. And vertical, so let's take a look at from graphical points. What is the vertical asymptote? What is horizontal asymptote? And what is the holes? And then we're going to take a look from the mathematically, how can we drive it, right? Okay, so let's take a look. Let me graph kind of, let's see here. Okay, so if I have the graph like this, all right, and then if I have something, let's say here, here, right? So I want to change it to a different color, and I want to get a little bit less here. Okay, so here, if I have something like this, okay, and then I have something like this. Okay. All right. So now, if we take a look here, okay, so if I have a graph, if my f of x, so the yellow one, this lines here, we are calling is the vertical asymptotes here. Okay, so this one, the yellow one, we call this the vertical. So we call this the vertical asymptote. And these green ones here, I'm calling this is the horizontal asymptote. Well, first we understand what is the vertical means. So the line is standing up, horizontal. That means the line is going like go flat, right? So the asymptote that means, so what is the vertical asymptote? That means if I have a functions here, right? So if I have a function, okay, if this the end of my functions continue getting closer and closer, you know, like every time, oh shoot, okay, so undo, okay. So like every time, you know, if I have a functions, right? So if the end is getting closer and closer to this line, but I will never touch the line. Of course, I did not do it right, and so it's very difficult to graph this. Okay, so let's try start over again. Okay, so here, let me do asymptotes here. Oh, shoot. See, that's what happens here. Okay, so if I do an asymptote here, okay, so that means if I have a line, if I have a functions, if this function is getting closer and closer, so this end, you know, like it's getting closer and closer to this line, but it's never touched these lines here, right? So this is what we call this the asymptote. And then your function can be approached from this way here. Like this is the functions, right? So this is also like here, you know, you will see this function is getting closer and closer to the yellow line. That's what we call it the asymptote. That means your function getting closer to it, but it's never touch it. So what is the, you know, then what is the horizontal asymptote? Horizontal asymptote is the same. So it's like, say, your function is approaching like from this, you know, you could approach like getting closer and closer to this horizontal asymptote, but it's never touch it. Or like here, you can do like this, right? So this function is here getting closer and closer to the horizontal asymptotes here, okay? So now what is the holes here? The holes is like this, right? So let's take a look at the holes, and then we can write down the definitions, and then that will be pretty good. And then, but let's take a look at the picture-wise. What is the holes here? Okay, so if this is the one, and now I have a functions here. Let's see here, if this is my functions here, right? So if this is my function, all right? So my function is to go from here to here, but then at here, really is just like the term you say, it's a whole. Then this function is a continue go like that, right? So that means we means it's the holes here. So this one's here, just like the picture show, we have a hole in the graph. That means this holes is not defined, right? Okay, so now we understand graphically what that means. So now let me try to write it out. What is the mathematical definition? Vertical. Okay, so how do I find this vertical asymptotes here? So the way we find the vertical asymptote, let me use a nice color. Okay, so the vertical asymptotes here, this color is not too bright. Okay, so it's x value, right? Because here they touched here, so this is the x values, right? So this is the x values. Okay, you find the x values here when set denominator equal to 0. So when you set the denominator equal to 0, then you solve for what is the x value. That's why you define the vertical asymptote. It's the 1, it's the undefined there, right? So that's good. So let's take a look at horizontal asymptotes here. The horizontal asymptotes here, see here, because in here you're doing here, right? So this is the y values here. Now, what is this y value? Is when the x approach to infinity or x approach to negative infinity. See here. So just like this end here, right? This numbers is continue going. So this arrow showing, that means x approach to the negative infinity. So like in here, also this one showing x approach to the positive infinity. So you will see what is the y values, you know, when x approach to the negative infinity or x approach to the positive infinities here. Now let's take a look at what is the holes here, okay? So the holes here, okay, you know, the holes is when denominator, when the denominator, when the x value make the denominator equals 0, but after factoring can cancel so can cancel out with the numerator. Okay, so what's that mean? Let's do one by one. So, but basically those are the definitions. So we're going to go over each one here, right? So let's take a look at the vertical asymptote. Vertical asymptote is the easiest ones here, right? Okay, so let's take a look at the first ones here, the vertical asymptote. Remember, we said a vertical asymptote is when the denominator equal to zeros, right? So, okay, so let's take a look at this example, the f of x. So this one is easy. So when the x make it with the denominator equal to 0. Solve for x, right? Okay, so when this one's here, this start with easiest function, -4 x plus 2. Okay, so we say the vertical asymptote is making the denominator equal to 0. So it's setting the x equal to, so it's setting the x plus 2 equal to 0. So I know the x equal to -2. So the first thing is here, I know that this one's asymptote. So the vertical asymptote is equal to what? X equal to -2. All right, so this is the vertical asymptote. It's very easy to find. Okay, now let's take a look at horizontal asymptote. Horizontal asymptote is a little bit, we have 3 rules here. Because I know my functions here, right? My function f of x is equal to the 2 polynomial px over qx. Okay, and let's try to put it like a qx is an xn plus an minus 1 xn minus 1 and to the a0. Then qx, let's say the bn xn plus bn minus 1 xn minus 1 to b0s here. Okay, so here is how do we define the vertical horizontal asymptotes here. Situation number 1. Okay, so we are comparing the degrees. Okay, so situation number 1 is here. So let's say if n greater than n, then we say no vertical horizontal asymptote. The reason why Is because that means x on the top is go a lot faster than x on the bottom. So it's going to the infinity. So there's no asymptotes there. Okay, so the situations, the number 2. Okay, so if n equal to n, so if they do have the, the same degrees, right? Then what is the asymptotes here? Then the horizontal HA is equal to y. So what is the horizontal asymptote? Will be the ratio of their leading coefficients, right? So will be the ratio of their leading coefficients here, right? So it's AN over BN, right? Okay, so now the situation number 3 is here. So this is the situation if n is less than n. That means the denominator running to the infinity a lot faster than the numerator. So if a denominator going to the infinity a lot faster, that means the denominator approach to zeros. The whole fraction approach to 0, right? So the horizontal asymptote is y equal to 0 here. Okay, so those are the 3 rules. So let's take a look at this ones here. f of x equal to -4, x plus 2, right? -4 really is what? You can rewrite this. This is x to the 0 power, right? Because x to the 0 power is what? Is 1, right? So then the x plus 2 is here. This is 1 power, right? So now if you compare the highest degrees, this is 0, this is 1. So the bottom is going a lot faster, right? So that means based on my rule, so my horizontal asymptote will be equal to y equal to 0. Okay, so that means, my graph here, of course, we cannot getting the detailed graph yet. That means for this graphs here, right? And I'm going to have like a vertical asymptote at x equal to 2, right? So the equal to 2, that means -2. So this is -2, right? So that will be the asymptote. And then my horizontal asymptote will be the same like the y-axis, right? So it's in here. So your graph, probably will look something like, something like go like this, go like this. That's what approaching to the asymptotes means, right? So, right, so something like that, right? Okay, so now, but we're not, we're not doing that right now. That's just you can pick up a few points, then you can get the details about your graphs here. Right now, I'm just doing a rough graphing. I did not pick up the exact points, right? Okay, now let's take a look at the second examples, right? So we have not talked about so this is example number 1. Okay, so now let's take a look at example number 2 here. Okay, so in here, if my f of x is equal to 2x x minus 3. Okay, so let's take a look at review the vertical asymptote. So vertical asymptote, right? So vertical asymptote is what? Is the denominator equal to 0. So is x plus 2, x minus 3, so x equal to 3. This is my VAs, right? Vertical asymptote. Okay, now my horizontal asymptote, right? So I'm comparing the highest degree, 2x, that means this is x to the first power, this is x to the first powers, right? And then if you compare, so this is the first degree and this is the first degrees, right? So they have the same degrees. So like we say, if they have the same degree, then what happens here? So the asymptote will just be, you compare the ratios, right? So that means the horizontal asymptotes here will just be y is equal to the leading coefficients, right? So the leading coefficients here is 2, and the leading coefficients here is 1 here. So the asymptote is 2 over 1. That means y equal to 2. So this is my horizontal asymptotes here. Okay, and now let's take a look at the example number 3. So in here we still don't have, don't have the holes yet, right? So let's take a look at example 3. Okay, so if I have f of x is equal to x squared plus 7x plus 12, and here this is x plus 4. Okay, so the first things that you look at is, okay, x squared plus 7x plus 12, right? So these ones here, I definitely can factor it. So this is x plus 4, and this is x plus 3, right? So this is x plus 4. Oh boy, so what did you see here? Hey, I can cancel the x plus 4s here, right? Okay, so in here, after you cancel it, this is x plus 3s here. But this x plus 3 is after you cancel here, right? Okay, so now let's take a look at let's take a look at the horizontal asymptotes here. The horizontal asymptotes is we compare the highest degree. So this is 2, right? So this is 2 degrees, x plus 4. So the x is 1 degrees here, right? So this is 2 and 1. So we say, oh, the top is greater than the bottom. So no asymptote. So here, that means do not exist, right? So it's a DNE, do not exist. So the horizontal asymptote is do not exist. Then you will say, okay, let's take a look at the vertical asymptotes here. So the vertical asymptote, you will say, hey, you told me the bottom equal to 0, right? So you say x plus 4 equal to 0, then the x equal to negative 4. So you will say, hey, the vertical asymptote will be x equal to 4. But no, it is not, all right? Because when you cancel that out, your function become x plus 3. So it's not, so like in here, I'm still is undefined, right? But this undefined, is not undefined from the asymptote point because they can cancel that out. So that's what these numbers here, x equal to negative 4, this is what we call a hole here. Right? Or you can say it's a 0 layer, or it's a holes there. So if you really, let's take a look if we graph it, right? Okay, so if you graph it, okay, so now let's take a look here. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, and okay. So like in here, you said, okay, let's try to graph it. So this graph is y equal to x plus 3, right? So you choose point. You said x equal to 0, y 1, 2, 3, 4, 5, 6, 1, 2, 3. Okay, so you say let's choose point. Okay, so when the x equal to 0, y equal to 3, so this is your first point, right? Then you say x equal to 1, x equal to 1. Okay, so this is like, you do a little tables here, so the x, y. So x equal to 0, y equal to 3, x equal to 1, y equal to 4, then x equal to negative 1, y equal to 2, negative 2 is 1, and the negative 3 is 0. Okay, so you can choose a few points here. Okay, so this is 0 to 3, 1 to 4, right? -1 to 2, -2 to 1, -3 to 0 here, right? Then when x equal to -4, it's not defined, all right? So then like if I said x equal to -5, so x equal to -5, y equal to -2. -5 is here, right? So y equal to -2 somewhere is here. Okay. Okay, so here, let's do here. So, okay, so when the x equal to -4, if you put this one, put the different colors here, right? -4, you will get the value is equal to -1. But -4 is here, you will get the value is -1. I'm going to put a very distinct colors here, because we know -4 is undefined, right? So even they have a position at a -1, but that number is not defined. So when you plotted it, then we know this is a line, right? So basically, of course, when I try to graph a line, it doesn't look like a line. And so here, oh, that even worse. Okay, so here, okay, so I should have used, okay, so here, that's good. So like, let me graph this one to see I can graph this better. Oh, much better. Okay, good. Okay, good. All right, so that's why we call it a hole here, right? Because you really have a hole here, okay? So holes, that means is the one you can what, you know, you can like, you can cancel that out from your original function. So your original functions really is kind of like a drop to become a linear functions here. Okay. Okay. Now let's take a look at let's take a look at one last example. So let's see. We can graph it, right? So we just did this. Okay, so this examples here. We just did this example. We already know. Let's try to see how do we graph it. This is a 2x. This is x minus 3, right? So we did it from the previously. We know the vertical asymptote is equal to x equal to the -3, and horizontal asymptote is y equal to 2. Now, let's see the few graphs here, right? Let's try to see how we graph this. Okay. Hope that I can do a good. Okay, not bad, right? Okay, so this is a 1, 2, 3, 4. 1, 2, 3, 4. All right, so now this is the 1, 2, 3, 4, 1, 2, 3. So first we know the vertical asymptote is -3, right? So I said, okay, let's do an asymptote here. And -3 is somewhere here, right? Okay, so. Okay, good enough, right? And the y asymptote is y equal to 2. So let's do something here. All right, so good enough, right? So we have this, and now we need to decide what function, how is my function going to go, okay? So the first things here, then the next things here you can do is try to choose a few points to help you to decide, right? So here you can say x and y. So because I know my graph going to touch those asymptotes here. Did I do this right? Oh, you guys did not correct me. X equal to the +3 is the, okay, so it's the asymptotes here. I hope I can erase this one. Hey, good. Okay, so oh yeah, of course you guys cannot remind me because we are not face to face. That's the bad part. All right, so here, see, that's why I missed the face-to-face. So if I make some silly mistake, you will be able to correct me. See here. Okay, so here, let's see here, right? So we can choose a few points to decide what is my curve goal. So first, let me choose when x equal to 0. Okay, so when I choose here, so I say when x equal to 0, then the y equal to 2, 0, so y equal to 0. So I have a point is here, 0, 0. Okay, and then let's choose something, x is kind of like the big, okay? So let's say the x equal to -3. Okay, so x equal to -3, so this is -6, -3 minus 3, so this is -1. So the x equal to -3 and, oh, +1, -3, +1, so it's here, all right? So it's kind of go up. Then let's choose something x equal to 2, right? Let's just try to see here 2. Then this one will be 4 is 2 minus 3 is -1, so it's -4. So here, right? So okay, so I said 2 is -4, so it's a go down here. Okay, so I got my function. So my function is kind of like go like this. All right. So of course this is a terrible drawing here, but as you can see, that means here, this is going, oh, okay. So that means here, this is going like this. Okay, so that's why this end going to approach. So this end going to approach the horizontal asymptote, and this end going to approach the vertical asymptote. And the one of the, so now you can choose another few points, right? So like you can choose when x equal to 4, when x equal to 4, so you will have a minus 4 minus 3 is 1, so it's 8. So you will get something like this, right? So you know, if you choose, also they are kind of always like symmetric. So you know your function, oh, that's terrible. I hate to draw this in the whiteboard because my function, golly, that's just getting worse. Okay, so now this one, do a good drawing here. Not bad, okay? Right, so that's what is your function will looks like, right? So like here, the same way, this end going to approach to the horizontal asymptote, and this end going to approach to the vertical asymptotes, right? That's what the graph will looks like. And so remember, so it's pretty easy here, the three things, right? The horizontal asymptote, vertical asymptote, and the holes here. And then this is the end of our section 10.3. Then the next section 10.4, we're going to talk about a very, very interesting function called the exponential functions. All right. So I hope you guys enjoy this, and you know, some of the students like it because it's graphing. Okay. So I hope you guys enjoy this, and make sure do your classwork. Okay. Don't fall behind, and talk to you later. Okay. Bye-bye.